I'm Doug Atkinson here at Solutions Review, and welcome to the Inside Jam Demo Slam. This year we were looking for a way to provide as much information as possible on the technologies in this space and asked the top solutions to send us a short recorded demonstration of their technology. Just as the name implies, the Demo Slam is intended to deliver lots of information quickly. So sit back and enjoy the show.
Actian, Avalanche, and Google Cloud have formed a strategic partnership to bring accelerated BI and analytics to data-driven organizations. Avalanche complements Google BigQuery by providing a high-performance data warehouse option for traditional operational workloads. It is a fully SQL-compliant MPP data warehouse that is optimized to deliver sub-second response for operational analytics queries on data sizes less than 500 terabytes. Avalanche runs 8 to 10 times faster than other cloud data warehouses on Google Cloud. Avalanche's performance advantage increases as concurrency and query complexity rises, giving you the industry's best price performance advantage on Google Cloud. Avalanche leverages key Google ecosystem technologies, including Google Kubernetes Engine and Anthos under the hood. Avalanche makes the user experience seamless by integrating with Google Cloud ecosystem data tools like Data Prep, PubSub, and Looker, and also comes with Avalanche Connect featuring pre-built native enterprise application and SaaS integration that are managed from a single unified user interface. Avalanche also features native Kafka and Spark data streaming support. Let's take a quick look at an Avalanche demonstration. Avalanche provides an interface for managing multiple data warehouses across AWS, Microsoft Azure, and Google Cloud. We use the same technology stack across all cloud providers to deliver seamless mobility. Avalanche provides support to scale your warehouse up and down as required for your business, and also provides connection options for ODBC and JDBC and output visualization. With BI tools such as Looker, you can easily access the Avalanche built-in query editor. Avalanche provides a complementary data set of airline flight data and a set of canned queries that you can use to quickly test out the capabilities of Avalanche. Let's give it a quick try. We don't even have to type any SQL. Let's say that you want to see the top 10 markets with the most destinations. We select it and hit Run. Get the query returned here at the bottom of the screen, and also populate a chart that we use to illustrate that most flights are going to Atlanta, Georgia, which makes sense since Atlanta has the most flights globally. In this demo, we created the dashboard for the flight dataset on Avalanche. Next, we do a refresh to ingest the latest dataset and then refresh the dashboard. Next, Avalanche provides the ability to be able to load it easily and quickly with built-in integration capability, providing wizard-like experience to build jobs. And we have a library of out-of-the-box connections such as CSV files that reside on your Google Drive and allow you to easily populate your Google Cloud Data Warehouse and Google Cloud Storage. Actian Avalanche on Google Cloud delivers advanced analytics with unmatched performance at unbeatable cost savings for multi-cloud, VPC, and on-premise deployment, with native integration within the Google ecosystem and beyond. It is tomorrow's data platform delivered to power the data-driven enterprise today. For more on Avalanche, visit us at actian.com/avalanche.
Hi, I'm Dave Mariani. I'm CTO and co-founder of AtScale, and I'm really excited today to show you the AtScale semantic layer platform. Okay, so let's go ahead and take a look at the product and see how it all works. So first, an orientation. What you see here is what we call Design Center, which is where we actually create and author and manage our models. What you see here is a finished model, and it's called, in the Sales Insights, happens to be on Snowflake, folder or project, and it's an Internet Sales Cube model. What you see in the middle, these are my objects. These include tables, like fact internet sales, as well as conform dimensions. And that's how we actually define our models. So it is a dimensional model, which means I can actually go ahead and take raw data from my data platform, and I can wrangle it and create calculations right here on this canvas. So for example, I could do things like create some inline transformations, like replace all of my nulls in my field, called sales reasons with another string like unknown. So by doing so, that actually creates a virtual column in this AtScale model, which I then can use and then share across other models. So you can see I've just replaced my nulls with unknowns. I can also create calculations. Like you can see here, I created a calculated tax. And I can go ahead and edit that. You can see there's a calculation that happens to be in the dialect of the native platform. In this case, it's a Snowflake dialect. Okay, so how do we create these models? Well, I can create right here in my canvas, and you can see I have all my data sources and my data platforms here, and all of the respective tables and objects that I can pull and drag and drop onto my canvas. I can also use importers. So we have the way we can also use samples that come along, sample models along with sample data that you can learn with. You can import Project XML, which is AtScale's XML format, so you can create templates. And then you can also import it from a variety of sources like Tableau workbooks. We can convert models in Tableau workbooks into an AtScale semantic model, as well as taking an AtScale, a Microsoft SSAS SQL Server Analysis Services cube and convert it into an AtScale semantic layer. So once we actually create these models, you can see that the output you see here on this Internet Sales Cube is actually, you see our dimensions and our measures. And unlike a data virtualization platform where you're still dealing with tables and columns, here you're dealing with a business-friendly semantic layer. So you can see that I have things like order quantity, sales amount, etc. That's very approachable. They're organized into folders. And then I also, for my dimensions, I have the whole concept of attributes as well as hierarchies. And so I can have my drill down paths. So this is something that's truly user-friendly and easy to use. So let's check out this semantic layer. So remember these folders in this format, and let's see how it looks in the various BI tools. And I'll show you for each protocol we connect to. So let's start with Tableau. So here you got in Tableau, you can see I'm connected to the Internet Sales Cube, and you can see I have all my metrics and my dimensions stored in these folders. So there's my sales metrics. I can go ahead and just double click, and that runs a live query against AtScale, which runs to the data platform. You can also see that I have my product attributes folder, as well as I have a hierarchy. You can see product line as the top, then category, and then product name. And by doing so, again, I've run a live query. So this is not a data extract. This is a live query, and AtScale is accelerating those queries and translating them into the native dialect of the data platform that we're talking to. No data movement, no building the cubes. Okay, so we saw what the semantic layer looks like in Tableau, and that was all done in running SQL. That was in SQL mode. Let's go ahead and take a look of what it looks like and what the semantic layer looks like from, let's start with Excel. So the good news is that any user with Excel can access AtScale without any client-side drivers. So if you notice here, I'm choosing the Analysis Services built-in connector because AtScale looks just like Analysis Services and speaks MDX. And this is going to be creating using my single sign-on, my Windows authentication, that's Active Directory. I'm going to go ahead and log on to and pick my Internet Sales Cube that you just saw me querying in Tableau in SQL mode. Instead, in Excel, I now have a live connection. I have my same semantic layer, which you can see over here to my right. And so you can see, of course, I have all my folders and all my attributes and all my metrics. So it's as simple as choosing my metric, and now I'm running live queries again against AtScale. In this case, I'm actually running it through MDX, and I'll show you what's happening on the back end. So you can see how fast that is. The great thing about this is it not only works with pivot tables and pivot charts like you see here, it also works with all the Excel cube value functions and cubex functions. And that's really powerful because that means that each cell in your spreadsheet can point to a cell in the AtScale virtual model. Again, there's no cubes here. These are just going to generate queries back to your data platform. So it's always live and it's always governed. So let's take a look at what that looks like in Power BI. So in Power BI, I'm going to go ahead and connect again using the SQL Server Analysis Services connector. So no extra thing to learn, no extra driver to install. And all I do is just paste in the URL that points to the AtScale service. You notice the default is this connecting live. So we're not doing an import into Power BI. You're going to see there's my Sales Insights project and my Internet Sales Cube model. And by doing so, I'm now connected live to that same metadata that I saw in Tableau, Excel, and now I'm viewing it in Power BI. And so rather than users having to model raw data, again, with a typical virtualization platform, you're dealing with tables and columns. If you're connecting live to your data platform, you're dealing with tables and columns. But if you're connected to an AtScale semantic layer, what you see is what you get. So that means that, as you can see here, that Power BI has now inherited that AtScale model, semantic model, that we designed in AtScale Design Center. That means the semantic model is being used across all these different protocols. And now we're actually dealing and we'll be generating DAX queries. So again, here's my metadata, here's my folders, here's my metrics, here's my dimensions, again in my folders, and let's go ahead and look at my order quantity by product. By color. So now what you see here is you see the exact same answer that I saw in Excel, and getting the same governance, the same answers, all without forcing your end users to have to deal with tables and columns and joins and foreign keys, and instead dealing with a very user-friendly, business-friendly interface. So let's now pop back to AtScale Design Center, and I'm going to go ahead and look at the AtScale query log, and I want to show you what happened right there before your eyes. So what you can see in the very beginning here in my session is that I'll come back and look at that last query we just generated. With that last query, the inbound query is a DAX query. So you can see, boy, I wouldn't want to have to write that. You can see that that Power BI generated that query from that interface, and you can see that AtScale generated, in this case, to a Snowflake query, and you can see that the Snowflake query that AtScale generated actually took advantage of an aggregate. So before your eyes, AtScale got smart and actually created an aggregate and used that aggregate in its queries. You can also notice that that the last query that I ran in Excel was an MDX query. So there's the inbound query, and again, here's the outbound queries. In the case of Excel, there's multiple queries because Excel generates totals as well as generating body queries, and that's all transparent to the user in Excel. And that very first time that I actually accessed and ran queries in Tableau, this is what it looks like in Tableau. So Tableau generated a SQL query. Again, AtScale generated an outbound data platform query, and it used an aggregate instead of rolling up from the bottom. In this case, the aggregate was 158 rows. So AtScale is going to keep those aggregates, those materialized views, up to date automatically. It's going to continually optimize and create them on the fly so that your experience for your query users, whether they're using BI tools or using Jupyter notebooks, is always going to be fast, and it's always going to be at speed of thought speeds. You can see these queries are less than a second in most cases. So that really gives you a good sort of tour of how AtScale works. Thanks for listening.
Hi, in this video, I will cover how you can sign up for RDA and get started with AIOps Studio. First, go to our website roboticdata.ai and then click on the free sign up button. Fill up your information here and you will get an email with a link to the sign up page where you can create account in the AIOps Studio, and that link is going to be this one, aiopstudio.cloudfabrix.io. Here, first click on the sign in with RDA SSO. Click on don't have an account, sign up, and say continue. Check for your email. In the verification email, click on the link. It will say email verified. Click on back to AOps Studio. Now say sign in with SSO. Make sure you select the latest version. Now your AOps Studio is ready. Click here and then give this command Studio and do Shift Enter. Here you can select various tasks. First, we are going to import solution packages, which has some of the sample datasets and pipelines. Use the URL that is provided to you. Click on download and view contents. Now you can verify the contents that are in the solution package. We have 4 pipelines, 4 datasets, and 1 formatting template. It all looks good. Say import selected. Import is complete. Okay, once you have imported the solution package, you can go and add a bot source. Okay, click on administration manage bot sources, go to add and select NLP CFX AI NLP bot and give the name NLP. Say check connectivity and add. Here it is asking you to restart the kernel, so you can go and click on this button, restart the kernel, restart, and then wait for it to come back up. When it says idle, then it is ready to be instantiated again. Now it says idle. Now go back to the cell and then do Shift Enter. Now let us verify if the bot source that we added, if it's effective or not. So go to Explore Data Automation Bots, type NLP, and now we can see that all the NLP related bots are active. So now let's go ahead and try out some of the sample pipelines and explore data sets. We had 4 data sets, right? So sample, you can explore this. You can also execute pipelines. Select edit a pipeline. You can review the content later. We have few analytics in the pipeline. Okay. You can inspect the output at every stage of the pipeline after it's completed execution. So let us say if we want to see the HTML report. So this was the report that we generated from the incident. Okay, so this concludes the video on how to get started with AOps Studio, how to sign up.
Hello. In this video, I will show basic operations in EasyMorph, importing a file, querying a database, and applying transformations to modify data. At installation time, EasyMorph will have created a desktop icon for quick launch. Starting the program shows the main interface for the system with 3 active areas. Main data operations are performed in the center. The sidebar shows context-specific options, and across the top are tab-delineated sections such as Project, Design, and Report, with the wizard section at Start. So let's start by importing data from a table. With the main tab active, we click on Import Table. The system gives us an option of importing from database, file, or generating data by other means. In this case, we're going to click on File and choose to import from a delimited text file. The system presents available files and shows me that states.csv is available. I click on that and open. Sidebar identifies the type of formatting in the file, and I apply. And now if we look in our main data section, we see we have an open file. A table with two fields in it, state long and state short. On the title bar for each field, I have a little icon which I can click on, and it shows me the options of changing the formatting of the data, modifying it, sorting, modifications, for example, of changing to upper or lower case, sorting, and ascending or descending. Now that we've imported a reference table, we'll move on to querying a database. We'll move to Start, and we're going to open the Database Connection Manager. This is a dialog for managing active imports from databases. And we'll start by making a new connection of a type SQLite. We're going to call it Companies, and we'll open the database file, which is already in our example, Companies. Open it, it's found the file, and we say OK. Next, we're going to query the database. We'll open the query editor. As we see, the connector is for type Companies, is automatically presented, and we'll choose Companies as the main table. This immediately presents the active fields of the database. I'm going to unselect them and choose Specifics. I'll choose Company, City, Workers, Revenue, and the short form of the state for the company. Additionally, I'm going to create a conditional import by dragging workers into the condition and state that I only wish database records where workers is greater than and a number, which I will set at 50. By leaving inclusive unchecked, it will give me records only with workers at 51 and above. 50 is not included. And I can see a preview where I see workers is consistently above 50. I can drag all the way through the list and verify my import. Since I'm now satisfied, I click on Impose to EasyMorph, and we now have two files in our active project: the reference table and our database. And just as in the database, in the reference table, I can see company, state, city, workers, revenue, and I can click on column identifier to give me an option of modifying the information or changing its format over in the active sidebar. Again, at any time, the active sidebar shows me available options that are context specific to the command I have chosen. Now that we have both a reference table and a database, we'll experiment with transformations. We click on Add Transformation to give, in the sidebar as expected, a list of available options. We'll choose to calculate a new column, and we choose the Company 1 database. We could equally drag and drop, for example, by simply taking Calculate New Columns and dragging it on top of the Company 1 database. At this point, we see Company database has the original import followed by a new unspecified transformation. The sidebar shows the available options. We will go and type in revenue per worker and choose the expression editor. The expression editor shows us the available fields, and the expression. So I click on revenue, mathematical function of division, and workers. And we see the expression is then built up revenue per workers. Clicking on OK has brought back to the sidebar revenue per workers is revenue divided by workers, and I apply. And if I go now over to Company One database and extend, I see there is a new column, as expected, of revenue per worker with a very precise set of unreadable numbers. I will click on the column and take from the sidebar in levels of 1000, which tidies things up considerably. Additionally, since I intend to link to the reference table and the company table, I note there is a misalignment. The short form of the state is in uppercase in the reference table, whereas it's in lowercase in the company database. This is easily rectified. I click on the column, drop down my editor, select Modify to uppercase. And as I can see, the short form of the state is now in uppercase, as it is in the imported table. Now we're ready to merge the tables. As we can see in the company database, our transformations are import, calculate a new column, and modify to uppercase. And we will now add another transformation, which is merge from another table. Click. And drag it on top of the database. And here we are. The sidebar again shows us the available options. State short, match to state short. We say that which we wish to extract is state long, and we apply. And we see on our database, we have now brought in the long name of the state from the reference table. So if we follow our transactions, we have imported a table, we have imported a database, and we have set 4 transformations. The original import, the calculation of a new column, the modification to uppercase, and the merge from the reference table. This concludes our introductory presentation of EasyMorph.
Hi, my name is Chris Gump, and I'm a solution architect at Equalum. Welcome to this introduction of the Equalum data ingestion platform. Today, we will provide a high-level review of several key features and functions of the Equalum platform. To begin with, Equalum is an extremely scalable and comprehensive data ingestion platform that combines advanced change data capture or CDC ingestion capabilities and high throughput, low latency ETL capabilities in support of both batch and real-time data pipelines. These pipelines can be built from structured, semi-structured, as well as unstructured data sources, where the data is read once using exactly one semantics and written to many target systems simultaneously using distributed processing techniques. In addition to these functional capabilities, Equalum provides a flexible deployment model that support on-prem and multi-cloud environments in order to tailor your deployment to meet your company's unique requirements. Now let's start with a brief overview of the Equalum user interface. The Equalum user interface is entirely browser-based, so no thick client installation is required. When you first log into Equalum, you are directed to the current master within the cluster. The initial landing page provides a dashboard of the cluster. On the upper section of the page, a dashlet showing the current status of the elements in the cluster and the resource utilization across the cluster provide the user an at-a-glance view of the health of the system. Below the status view, the dashboard is divided into 4 panels. The layout is designed exactly the way the user would configure their data pipelines, with sources on the left, targets on the right, flow definitions in the middle left, and flow executions in the middle right. In addition to these dashboard panels, on the far left-hand side, the user has a launch pad to quickly access various items in the system. The top icon is an icon that will return the user to this dashboard. The second icon will provide the user a per node view of each node within the Equalum cluster. The next icon is the source management view, which provides the user details and status of each source definition within the cluster. The next icon provides the user access to the agent management view, which provides a view of each of the agents running within the cluster, their current status, as well as each of the sources that are running within that agent. The next icon is the flow management view. The flow management view allows the user to view and access each of the flows that have been defined in the system, filter on the views for particular tags or names of flows, or even version details or time details accordingly. The next icon is the flow execution view, which provides a similar view as the flow status view, but in this view, the user has access to the details about the actual execution of the previously defined views or previously defined flows. The next icon provides access to the target management view, which provides a high-level status of each of the targets and access to their configuration definitions. The next icon provides access to the alert management view, which provides the user high-level access and interactive access to all the alarms running in the system or active in the system, as well as the ability to interact with those alarms by acknowledging those alarms and adding event notes or details as they are troubleshooting various problems within the system. Finally, the last icon gives a quick access to the event streams available within the system and shows details about their current status, as well as access to data that's currently residing in each of the event streams. That concludes our brief introduction of the Equalum platform and a high-level overview of the Equalum dashboard. Please keep an eye out for future videos where we will dig deeper into specific aspects of the Equalum platform. Thank you and goodbye.
Customers today are concerned about being able to cut costs, modernize their storage, and better manage their multi-cloud strategy. This demo will show you how Komprise can help you achieve all three and become a data-driven enterprise. We'll show you how you can know and understand your data, better plan your multi-cloud data management, and transparently move and manage all your data across all silos and without disrupting data access. Just download Komprise and set it up by simply pointing it at all your storage. Here, we're connecting to NAS storage, and you can see all the different types we're connected to. Within minutes, Komprise shows you valuable analytics on all the data. First, the heat map shows you overall how much of your data hasn't been used and how long. You can see that 50% of this data hasn't been touched in over a year. The problem is that this cold data is using expensive storage and backup resources. Historical growth rate analysis shows that this nearly 3 petabytes of data is going to grow to over 4 petabytes if you just keep doing the same thing. Get to know your data and see how the business is actually using it. See the different file types, see if they're big or small files, which users or groups are accessing them, and know where the data actually sits. This information is valuable for IT to both understand how data is growing and how to manage it more strategically. You can set your own policies and run what-if scenarios to project the cost savings of different data management strategies. Want to get rid of data you no longer need? Find out the impact. One company saved over $400,000 in storage and backup costs by deleting all ex-employee data, and then they put it toward new flash storage. You can set different policies on what data to archive and then transparently move your cold data to either an on-prem object store or cloud store. Komprise automatically updates all the cost savings so you can instantly see the results of your different scenarios. You can get all this powerful analysis and forecasting before you make any storage purchasing decisions. Komprise can also make a copy of your data on an on-prem object store or to the cloud. That reduces your costs for your mirror NAS by putting a low-cost second copy in a cloud, not in a second data center. Once you set all your policies, just activate and Komprise starts archiving the data based on your instructions. But what doesn't happen next is just as important. We all know end-user access after archiving data can be problematic, but not with Komprise. To end users, data appears exactly where it was before and opens the same way. Only the tiny arrow shows that it's now a remote file. Users won't notice the difference, but you'll notice serious savings by archiving all your cold data to less expensive storage. But that's not all. Let's say you just want to move data from one storage to another. Komprise makes migrating data easy. Just pick your source and destination, and with a click of a button, Komprise does the rest quickly. With Komprise Elastic Data Migration, you can migrate fast and reliably over a LAN or a WAN. Want to kickstart that AI or big data project? Komprise makes it easy to search across all your storage to find specific data fast. You can easily create a company-wide virtual data lake for custom queries and tagging. All of this powerful capability and cost savings is yours with one solution: Komprise Intelligent Data Management. Take a test drive in your environment to see for yourself.
So how do we actually do it? This slide actually gives you a better understanding of how we work. Now, this is an example of a typical BI infrastructure that we see amongst our customers. On the left-hand side, you can see an example of different business applications that are being used by business users. Those business users are entering data into those systems in large quantities, and they consume this data in return. However, they don't have access to this data, and this is why the BI team is responsible for making this data available to the business users. And this is why at any given point in time, the BI team needs to know where the data is and understand its movement process through the BI systems, meaning where it's coming from and where it's going to. This may be due to reporting errors or impact analysis issues. Now, since the metadata is scattered all over the BI landscape, our customers tell us that BI groups spend more than 50% of their time just trying to discover and understand where the metadata is, in order to understand the relationship, connections, and the data lineage. And in order to overcome all of these challenges, we developed a cross-platform automated SaaS solution that extracts all the metadata and centralizes it for you in one place, analyzes it, and makes it available to you from many systems. We are able to do this by simply extracting the metadata from different BI tools. This is then uploaded to our cloud for analysis. And then within 24 up to 48 hours, you get a detailed picture of your BI landscape. So what I'd like to do next is actually share with you a short demo of our platform. So what you're currently looking at is our user-friendly dashboard. On the left, we have different modules that are being supported by our platform. We have the lineage module, and within the lineage module, we actually support 3 layers of lineage. We have the cross-system lineage, where on a very high level, we connect between the different systems, between the different ETLs, databases, analysis, and reporting tools. And this is where we show you all the tables and all the views. We have the inner system lineage, and this is where we focus on a particular process, like an ETL or report, for example. This is where you'll be able to see all the transformations, all the calculations, and all the maps. And then finally, we have the end-to-end column-to-column lineage, and this is where we focus on a particular column from the moment it entered the BI landscape all the way through to reporting and analytics. Now, another module we have here at Octopai is the discovery module. The discovery module is when there is a need to search for a specific item in the entire BI landscape that is connected to Octopai. It can be a field, a line of a code, a word, a calculation, or a text, for example. This module provides a more technical information about the different objects. And then finally, the last module is our automated data catalog. This module helps companies and organizations to manage, understand, and discover data assets in a better way, and enables the capability to add business information for the assets such as tags, descriptions, ratings, sensitivity, data owners, etc. Now, what I'd like to do now is actually demo the power of Octopai with reference to a few different use cases within the BI landscape, of course, which will touch on the various modules within the platform at a high level. And the first use case I'd like to start with seems to be the most common one among our customers. And this is when there is an error in a report. Now, let's say a support ticket is issued by a business user asking the BI team to investigate the problem in the report to see how the data landed on it. Those responsible will now need to reverse engineer the report. Now, this process is usually done manually. It takes a lot of time and usually involves different people from different departments. Now, this wouldn't be the case while using Octopai. So let's see how we would address the challenge for you. So Octopai will search through the various BI systems to gather the metadata. And here and in one place, we can see where Octopai gathered the metadata from. So you can see that the metadata we collected is represented by different ETLs, store procedures, database objects, files, and finally, reports. Now, back to our use case scenario. Now, traditionally, what happens is that the data intelligence team would need to investigate how the data landed in the report. In order to do that, they would need to investigate the structure of the report and the reporting system. Then it all needs to be mapped. And then they would need to contact the DBA to understand the exact name tables and views that were related to the creation of that report. They would also need to understand if the fields or labels are given the same names, and if not, which glossary was used. And even after they've investigated all this, which may take a few days, the DBA may still say there is nothing wrong with the table and views. However, maybe something changed in the ETL processes associated with these tables and reports. Now, this may take days, weeks, or even longer. Now, what I just described is a typical scenario of how the process works nowadays in most organizations. And what I'd like to show you now is how it can be done at Octopai in a matter of seconds. So what I'm going to do next, I'm actually going to search for a report. And the name of the report with the issue is Order by Sales Rep Summary. Now, as I type the name of the report, you can see that Octopai already filtered through relevant ETLs, store procedures, database objects, files, and reports. Now, we can actually see that this is Power BI report. Now, clicking on the lineage of that report, we can actually see the first layer of lineage that I previously mentioned, and it's cross-system lineage. And in a matter of seconds, we can actually see the entire infrastructure of the report at the cross-system level. Now, in most organizations, this may have taken hours, days, or even longer to obtain. Now, I'm going to open the legend, so you'll be able to see the different colors, the ETLs marked in blue, the databases marked in red, and then the report itself marked in green. Now, what we're going to do next is actually dive into the report itself to find the column total due sum that we're having trouble with by looking at the inner system lineage transformations and logic of that report. And the way to do it, all we need to do is just click on the report and click on the report view, or in other words, inner system lineage. Now, what we're able to see here is the inner system lineage of this Power BI report that shows a map view of the source, transformation, and target columns. Now, in case you have any calculations there, all you need to do is just click on the formula here, and you'll be able to see the expression itself here on the right. Now, the next thing I want to do is actually click on the column itself, total due sum. And by clicking on it, we will be able to see the inner system lineage of that column. Now, if I need to understand the end-to-end lineage of this column, all I need to do is simply click on the three dots here and choose end-to-end column lineage. And in a matter of seconds, it will show us the end-to-end lineage of this column from the moment it entered the BI landscape all the way through to reporting and analytics. Now, in order for me to get a complete understanding of this column, I need to understand the business meaning of it. And in order to do that, all I need to do is simply click on those three dots again and choose View in Automated Data Catalog. And it will actually show us the asset description in the data catalog, completing the picture and providing us with all the necessary information to make the necessary corrections.
So there you have it, a demo slam. We hope you found this unique virtual showcase of industry solutions beneficial. We tried to compress a lot of information into a small amount of time. That's what the Insight Jam is all about. We appreciate you sticking around till the end. Thanks for watching.